Hello everyone, welcome back to the Tech Tips mini-series. This mini-series is going to be focused on installation and more importantly the best practices associated with installation on ductless split systems. So let's go ahead and dive right into it. So we're going to start with the indoor unit here. So with the indoor unit, just some basic considerations we need to make sure that we're looking at when installing equipment and also where the systems are going to be applied at. So we always want to make sure that we follow the recommended installation clearances for proper maintenance and more importantly, airflow clearance to ensure that the discharge and the return of the indoor unit are clear. We want to make sure that we're not using these indoor units in spaces with corrosive, hazardous, or flammable chemicals. We want to avoid installations that are too close to an external heat source, such as placing a unit behind the backside of a refrigerator where radiant heat can hit the return air sensor and cause the unit to shut off prematurely. And we also want to make sure that we position the unit at least 40 inches away from any smart enabled devices such as smart TVs or any other smart appliances around the home to make sure that we're not going to run into any signal interference on our S or signal wire. So for indoor unit clearances, we're going to start with the high wall indoor unit. So with this one, from the top side of the unit for minimum space to allow for proper return airflow, we need at least 6 inches from the top side of that unit to the ceiling itself. If you look on the diagram, you see from the left side and right side, we need at least a minimum of 5 inches for service clearance around there, and then at least the unit to be mounted 6 feet from the floor to where the actual unit is located itself. For our cassette style indoor units, you can see here, they obviously have that recessed type installation. So on either the left and the right side, we want to make sure we at least have 5 foot of room on side of there, not only for, not so much for airflow clearance, but more so for serviceability, that if we need to get up there and work with the condensate drain line, or if we have a leak and need to access the refrigeration fittings. From the unit itself, at least needs to be 10 foot from the space that it's in reference to the actual floor itself. So 10 foot at least up into the unit, which is typically about 10-foot ceilings are typically the design condition for most homes. Now inside of the cassette unit itself, you'll see on here we have 2 main connections up there. We're going to have the point of condensate management or the condensate removal, which you'll see there with a little flexible drain line, which this unit does have a built-in condensate lift pump to essentially lift the water either to a secondary pump or a natural drain. And then of course we have our refrigeration line set connections on there as well that will be accessed either if we have a leak issue or on the initial startup. The nice part about these units is on the bottom side, there's 2 clips that open up to allow this unit from the bottom side, which you'll see right here where the actual beauty plate, will drop down and you can access your fan motor, your condensate lift mechanism, and then also your electrical section in there to do all your service work aside from the drain pump line and the refrigeration line sets all from within the space that the cassette is serving. For our floor consoles, if we're doing a recessed application where the unit's going to sit back between a wall area, we need to make sure that not only on the top, but on the left and the right sides that we have a minimum of 4 inches on the top, on the left, and on the right for service clearance for that unit. Okay, now one thing we need to consider on here on the front side is how this unit opens. There's 2 tabs on the very top, right here and right here, that you push together and the front part slides out. This is where you're going to access your coil, your filters, and then more importantly, your electrical section to do any installation work, or on the post-sale side, coming back for service work, depending on if there is an issue with the system or not. So we need to maintain at least 40 inches of space so that can properly open and close so that we can get in there and service that equipment. And of course also too, to make sure that we can get the proper return and supply. And you can see on this one, return is coming in at the bottom, discharging at the top. Now, when we deal with our ducted style applications, we first want to make sure that the unit is actually supported properly and hung properly. So you can see up here, we have our little arms that hang off of the unit itself, followed by our all thread, and our locking nuts. Now this can be supported either to a direct structure, or we can use unistrut to help suspend this unit. And then we need to make sure that we put our level on top of the unit and make sure the unit is level and not sitting too far left or too far right. Now on the right side where your refrigeration connections are, we're going to need at least 12 inches minimum of space to get in there to access those service fittings, not only for the initial install, but also on the back end if we have to go back in and repair a leak. On the opposite side, which has the drain connection on there, you at least need to have 4 inches. Typically, I'd say 12 inches is more than enough on each side on there, but in tight applications, the minimum for service clearance to get in there would be 4 inches on the left-hand side, and on the right-hand side with our refrigeration connections, at least 12 inches. Now, if we're dealing with a ducted unit that is installed vertically versus the traditional horizontal path, those same rules apply. So on the side with your refrigeration access fittings, we need at least 12 inches of clearance. Now that only changes when we step up to a larger ducted unit, such as the 4-ton and also the 58,000 BTU. And you can see in here I have circled in red. This requires just about 16 inches of clearance just because of how this access panel is on these larger style units. Now on the right-hand side, we still maintain that minimum of 4 inches. Okay, and again, this is a vertical style installation, not horizontal. Now with the ducted unit, this is an application that I wanted to bring up on here to make sure that we don't run into the circumstance again. So this unit was installed upside down. Now there's a few different ways that you can tell that. First is going to be, look at where the hangers are. So these hangers are not meant to rest, in this case, on the unistrut. These actually need to be on the opposite side so that they can properly suspend the unit. So that's going to be the first giveaway, is looking, are the arms of the hangers off if you're on the bottom side? If they're on the bottom, the unit's upside down. They need to be up at the top. Secondly, the sticker's upside down. Now, this could be something that was improperly installed from the factory on mistake, but we don't want to make that assumption. The best surefire way to tell on this is looking at where your support hangers are, but in this case, the sticker was placed properly and it's upside down, giving us an indication that, hey, this unit's installed upside down. Now, the biggest thing is you'll see these 2 drain lines on here. And with this application, this is where the mistake occurred, because they turned the unit upside down because they were trying to use this drain connection to drain out as they did. Now, the issue with that is that this right here, if it was installed the other way, would have been the drain connection that they needed to hook up to. This one right here is when the unit is installed vertically and we bypass the pump, so we allow only a gravity drain to feed out either to a drainage system or a secondary pump to get that condensate water out of there. Another great indication of when you have a unit installed upside down is you'll hear the fan motor intermittently come in and out of operation, and it's not producing enough CFM to be able to condition the space. Now, unfortunately, in this case, you can see on the bottom side, they drilled into the bottom side of the unit and tapped out, and they also have the same situation on this side here with their supply air. So in this case, in order to correct this, not only do we have to patch the holes that they cut on the bottom side of the unit, but now we have to unhook the unit, reinstall it the correct way, hook up the drain line properly, and then make sure and retest that the unit is giving the proper amount of CFM and BTUs to condition the space. And again, this all could have been avoided if they would have just looked at where the support hangers are. So in this case, we're looking for the support hangers at the top. We're looking to make sure the stickers match up. And then another great way to tell if a unit's upside down, these units have a bottom return option. So you'll see on here, this is all one solid piece of metal. If you were to look on the top side here, there is a set of Phillips head screws that the bottom panel drops out, and that's the bottom side of the unit. So that's another great way to tell that your unit is in the correct position. But again, the surefire way to really make sure that that is not the case you're going to run into is looking at where the support hangers are. Okay, again, in this case, if they're on the bottom, the unit's upside down. They need to be at the top. So on our ducted style units, we do have adjustable switches on here that we can set for static pressure. Please be aware that the units do not come set with the maximum static pressure that they can output. So don't assume that you're automatically going to get the amount of static pressure you need. to satisfy the spacer spaces that this ducted unit is serving. So for example, on the sizes 9 and 12,000 BTUs, our default setting is 0.08 inches of static pressure. It's really not much, and these units are typically designed as a straight shot and cannot facilitate multiple takeoffs or multiple rooms to condition just because of the minimum static pressure that we have. Now you can see if you adjusted this to the maximum on there, you're only dealing with just about 0.2 inches of static pressure, which isn't much at all. Again, smaller units such as the 9 and 12 are geared towards more of a one-to-one application as far as ducting is concerned. We really can't facilitate any takeoffs on there and be able to provide the correct amount of CFM to that space. Now, if we move up in size to the sizes 18 and 24, you'll see the default setting is 0.16, and the maximum static pressure setting is 0.4 inches of static, which with that, we have a little bit more flexibility on what we can do as far as a couple different takeoffs. But again, these systems aren't designed to have 5 or 6 different takeoffs. Typically about 2 to 3 on average is what we see, and that's more than acceptable. And then finally, on our larger sizes, such as the 36 and the 48, our default setting from the factory is 0.2 inches of static, and the maximum that we can push out of that as well is going to be 0.4 inches max. Okay, just something to keep in mind on there. This also can be done from our wireless handheld remote controller. For those of you that have attended the advanced operation class where we went in and adjusted fan speeds after a set point, that same menu is where we can get into for the ducted style units and the vertical air handling style units to go in and adjust for static pressure to meet the certain application that we're dealing with. So as I stated before, when we were taking a look at the picture of the unit that was hung upside down mistakenly, you have 2 options that you can do for return air into the unit. You can do a horizontal return air, or you can do a bottom side return air. And you'll see here that this panel comes with a set of Phillips screws that you can take off and remove, and you can remove this bottom panel. So essentially you're taking this, putting it on the bottom, and taking this cover plate and plugging up the top. Okay, so this is really nice, especially for apartment style applications, where you can set up a removable grill to access where your filter is and also access where your fan motor is on the bottom side. One thing to keep in mind when you're suspending these units, you want to make sure that you leave enough clearance on the bottom side, especially on the horizontal style installations, where you can access your fan motor in case you need to get back there to clean a wheel or if a motor decides to fail. Because if this is just resting on a steady platform and it's resting on the entire surface area of the bottom unit, you have no way of accessing that blower motor other than cutting into the ductwork, removing it, and then getting in the back side of the unit there. So something just to keep in mind, please make sure that you allow for proper service clearance on our indoor units so that you can access the fan motor. Otherwise, you're going to put yourself in an extremely difficult situation on trying to access that fan motor, whether it's for cleaning or whether if the fan motor has decided to fail. And again, don't assume that the units are set up automatically to recognize airflow such as static pressure and the amount of CFM. We still need to take our load calcs for the individual spaces. We still need to look at the product data of the units to make sure that the unit that we're selecting is going to give us the appropriate amount of static pressure to output proper airflow into the spaces that we're trying to serve. For example, the 9 and 12,000 BTU units are only going to give you about 0.2 inches of static max on those. So those are going to be best for one-to-one applications with no takeoffs. While the larger style ductless units that can do just about 0.4 inches of static pressure max can facilitate a couple of takeoffs if you're trying to condition multiple spaces off of one ducted ductless indoor unit. So please make sure that you account for that and to make sure that you don't run into any issues during any future installations. And of course, if you have any questions on something or you can't find literature that will give you that information, you can always call me or one of the guys in technical service here, and we can be able to give you that information so that you have that information to make an educated decision. So we talked about the indoor units. Let's go ahead and move on to the outdoor units. So just some basics with the outdoor. We always want to make sure that we follow the recommended clearances for proper maintenance and airflow, just like we did with the indoor units, same concept. And just like the indoor units as well, we don't want to use these in spaces with corrosive, hazardous, or flammable chemicals. We want to make sure that we install the unit on a pad or raised off of the ground Typically in this area, raised off of the ground or a wall mount condensing unit bracket is acceptable. And of course, it's going to be raised up to the anticipated snowfall minimum, which typically about 12 inches around in the Pittsburgh area is more than enough. If we move up north or areas that experience high snowfall, we need to make sure that we have that unit lifted off the ground. If we don't, snow will build up on the side of the coils, block the amount of airflow that can get to the unit, and of course we know it will not properly defrost, and it will also reduce heating capacity. So the units do need to be lifted if they are going to be in an area that experiences not only cold conditions, but more importantly, the high snowfall where it could build up around the condensing coil. And of course, the preferred installation location is going to be somewhere that's well ventilated. We don't want to stick this inside or an area that's not going to be well ventilated where we can get good air coming across the coil as we are in different heating and cooling modes. So for clearances for our outdoor unit, you can see on the diagram on the left, and then the A through E selections up on the top right of the screen are going to be our minimum clearances that we require both on a single and a multi-zone configuration. So let's look at point A on here. So point A is going to be from the top side of the unit to the object that's going to be directly above it if there is one. We need a minimum of 24 inches of clearance there because this top cover needs to be taken off to gain access into the electrical section. We look at B for the refrigeration service fitting side. That's going to be for service clearances so that we can get in here, properly install, and do any maintenance or service as time allows. If you look at C, it's going to be from the condensing fan motor out to the closest object, if there is one. That also is going to be 24 inches for proper air discharge so we're not recirculating back into the coil and short cycling a unit. D, which is going to be from the left side of the unit, the coil, out to whatever nearest obstacle, if there is one, is 4 inches. Okay, now again, this doesn't mean cram this against the wall until it's 4 inches. You still have to get into that coil to do coil cleanings on it and also get around for service access. So again, that's the minimum. Typically about 12 to 24 inches is usually what I recommend for point D. And then finally E on there, from the unit, typically when it's mounted on a stand to the wall, is a minimum of 6 inches, and I have to correct that on there. It's not 6 foot, 6 inches from the back side of the unit to the wall, not only for service, but more so for proper air intake into the coil itself, depending on what mode we're in. Okay. Now, when we look at the bottom style, we have a larger ductless application where we have multiple ductless systems. If you have a row of ductless units, so in this case, we've got 9 ductless indoor units on this rooftop application. When the units are going to face each other, so we have condensing fan motor on this system and condensing fan motor on the opposite system, pointing in the same direction, you must maintain a space between those two condensing fan motors of 59 inches to ensure proper discharge air from that outdoor unit. Okay, it's very important, you see on the back side here, that these units aren't going to face the opposite way, so that if they're discharging their condensing air into the back side of the other coils. Come heating season, this causes a lot of issues, especially frosting issues. We've had it happen on an application before, and unfortunately the only thing that we can do is move those units away. So if we have a row application, we need to make sure that the back side of the coils that are facing each other and the discharge side of the outdoor unit are all facing in the same direction. And if they are facing each other in this particular circumstance, we need at least 60 inches to ensure proper discharge air out of the unit so that we're not recirculating anything or causing any operational issues. Now, when the units are installed side by side, like you see here, we need to make sure that we have a minimum of 10 inches of space between the units for proper airflow. Typically, I'd like to say between 12 and 24 just for service access, but if you do have to keep them close just because you have to maintain a tight parameter because you're working with a very small space that you have to put these units in, the minimum we have to have on there is at least 10 inches for proper airflow from the sides of the indoor unit. Now, when we look at the multi-zone ductless systems, the biggest issue that we run into with these is going to be the overheating process. The overheating on these systems is a result of two things. The first biggest one is going to be that during the heating mode, the multi-zone ductless systems and also the single-zone ductless systems cannot shut their EXVs 100%. The reason we cannot shut them 100% is because we can facilitate long piping lengths. Oil return is crucial on these systems, so we have to maintain a minimum position so that we get a constant refrigerant and, more importantly, oil flow or circulation out through the system and back to the compressor. Now you pair that with our indoor units, regardless of whether it's a ducted, high wall, cassette style, or floor console, that always run their fans at a breeze speed as a factory default, you get overheating. Now you can, however, go in and configure the fan speeds to shut off after set point, but that does not change the fact that refrigerant is going to be circulating to one of those units, regardless of whether all of them are calling or one of them are calling. Okay, now if you look on the picture here, you'll see if this high wall unit was in an active call for heating, the other units are going to have hot gas circulated through them, and that, again, that is to circulate a minimum amount of return oil back to the compressor. They have to maintain a minimum position. The EXVs will never be fully shut. And this is what leads to the overheating of the space. And this is also something that we need to take into consideration when we are applying these systems, especially in areas with different thermal loads, such as different temperature requirements, or areas that have greater heating loads than others that are on the same system. Okay, but a good rule of thumb is understanding that the EXVs do not shut 100% in heating mode. Paired with the indoor fans running at a breeze speed, this leads to overheating of the space. It's a misapplication issue. So some things that we can do to try to deal with the overheating is first going to be, if we have an application, let's just say we have a unit in the basement, and we're not really too much concerned with what that basement temperature is. It's kind of just tempering that air. If it's a little bit too warm or a little bit too cool, it's not a big deal. Well, we can configure that basement unit essentially to be our dump zone. So how we do that is, if we have a two-headed system here, and we look at the first floor unit, our space temperature 68, the set point 72. So we know that this unit is an active call for heat. So not only is this one getting hot gas, but this unit in the basement is getting hot gas. Now let's look at its set point. The space temperature 67, the set point 65. We know that this unit is technically considered thermo off, but it's still getting hot gas and it's still running its fan at a breeze speed. Now you can see that because the set point 65 and the space temperature 67. So we're slightly overheating. So what we can do is we can go to our first floor unit and we can program this fan speed to shut off after set point. Once this fan speed shuts off after set point, that doesn't change the fact that hot gas is still going to flow to this indoor unit. So what happens is this creates a hotter coil temperature or surface coil temperature. While the basement unit, we leave that fan running. While that fan runs, that creates a colder coil temperature. Now, when I say colder, I don't mean 50 degrees, but it's much cooler than our first floor unit. Now, if we look at this from a scientific point of view, we know that the second law of thermodynamics states that heat goes from a hot to a cold surface. So in this case, this coil is going to be hotter, this coil is going to be colder. So that heat, excess heat from the system, is now going to migrate to the basement unit with this fan running. So this becomes our dump zone while we've addressed this unit to make sure that it does not overheat. Okay, so this is how we configure a two-headed system to use the basement unit, or the area that we're not concerned with space temperature, to be a dump zone. This isn't applicable for every single job out there. To be honest with you, we're really not going to see an application where one of the units isn't going to be a space temperature concern. But if you do have an application like this, this is one step or one action that we can take to try to offset a unit overheating by playing around with different fan speeds. Now, typically what we see is if we have a two-headed, three-headed, or four-headed system, we're going to shut these fan speeds off after set point, which is done by accessing the advanced service menu through our wireless remote controller. Okay, and on the high wall style units, we do that because of where that return air sensor is located. If you've ever serviced one of these units, if you pop open the front cover, and you take out the right side filters, you'll see there's a little plastic tab that slides right into the indoor coil fins. And inside of that is your return air sensor. And it's all of about 3 to 4 inches away from that indoor coil. So if you were to just shut the fan speed off and not relocate the return air thermistor, what would happen is that refrigerant flowing into the indoor unit, which we talked about as that minimum refrigerant flow or oil return, we're not changing that. That coil is still going to get hot. We shut that fan speed off, and now that residual heat is going to come up and hit that sensor, and it's going to go from overheating to not heating at all because that sensor thinks it's 85, 86 degrees because of the residual heat that's rising off of the coil now because we shut the fan motor off. Okay, so what we need to do is not only program that fan speed to shut off after a set point, we need to relocate the return air thermistor to the right side of the unit. Okay, and again, that's to make sure when we shut the fan speed off that we're maintaining and reading an accurate room air temperature so that the system functions to the customer's expectations. Another thing that we can do on these is we can enable the follow me mode on the remote controller. Now, I'll be 100% honest with you, the follow me mode hasn't been the most consistent mode. So this is usually something that I'll do with you when we're troubleshooting to confirm that the system actually is picking up on residual heat, which would have to have us relocate that return air thermistor and shut the fan speed off after set point. So you can think of the follow me as a temporary solution until you can relocate that return air thermistor. Now, I call that a temporary solution because the follow me, I've seen periodically drop out of the follow me mode with inactivity on the remote controller. And then more commonly, that when the system is enabled in follow me, it relies on line of sight communication with its indoor unit. So if you have a customer that you put it in the follow me mode, it resolves their issue, the fan speed shut off, and then you leave and run your next service call, and the customer puts it in a drawer or their kids take it and they get it lost. And it defaults back to the return air sensor if it's not within line of sight to that indoor unit, and then the problem returns, which is why we call that a temporary solution, while relocating the return air thermistor is more of a permanent fix. If you have a system that has a 24-volt interface and you need to configure the fan speed to shut off after set point, the nice part about that 24-volt interface is that it takes temperature from your third-party wired thermostat on the wall as a default. So it's not taking the return air temperature. So you already have something taking external temperature outside of the unit. So you don't have to relocate the return air thermistor. The only thing that you would have to do with that application is just shut the fan speed off after set point, which is done through your wireless handheld remote controller. Okay, so those are going to be the two options. Again, the first option is typically going to be relocating the return air thermistor to the right side of the unit outside of the cabinet so it reads a true return air temperature, and also programming our fan speeds to shut off after set point. If you have a 24-volt interface, the only thing you need to do is just shut the fan speed off after set point as the interface reads temperature exterior to the unit as a default. So getting into the piping installation. So when we're going and starting our installation, we need to make sure that when we are cutting our copper pipe that we're cutting it correctly. So you can see on the left-hand side, you want to make sure that you have your cutting tool properly aligned and that it's not sitting at an angle so that it cuts that pipe and essentially puts a bend in the pipe. You want to make sure it's a good, clean cut. Otherwise, our flare is not going to be correct when we go to do our flaring process. Okay, so you can see on the left-hand side, that's correct. On the right-hand side, you can see we're off center a little bit. So you definitely don't want to cut the pipe like that. After you cut your pipe, you need to make sure that you're deburring your pipe. Because we are making a mechanical press fitting, we need to make sure that when we deburr, we have our pipe facing downwards. We take our deburring tool and slowly work that pipe to clean up those edges on there, and then just give a soft blow through the pipe or get a rag and clean up those little metal shavings, because if they sit on the pipe when you go to press down and make your flare fitting, they can cause nicks in the surface of the flare, which can lead to refrigerant leaks over time. So again, it's all in the preparation. We need to make sure that we're cutting correctly. We need to make sure that we're deburring facing downwards and getting those metal shavings out of there. Okay. Now, when we go to do our flares, you want to make sure that you have an R410A dedicated flaring tool. Now, the difference between the flaring tool you may have got through an apprenticeship or at school, depending on if you've been out of the school or apprenticeship field for a while, the only difference between those is the concentric cone is thicker on the 410A flaring tool, which leads to having a deeper flare or a stronger flare. And this is because we deal with higher operating pressures on a 410A system than we do on the older 22 style systems. So we need to, one, make sure that we have an R410A dedicated flaring tool. And then secondly, we need to make sure that we are torquing down our flare nuts. Good and tight does not cut it. We need to make sure, one, what is our diameter of pipe? And two, what foot-pound of torque that we need to torque down on that flare nut. So for this example, you'll see 1/4 inch requires 10 to 13 foot-pounds of torque. 3/8 pipe requires 24 to 31 foot-pounds of torque. 1/2 inch requires 37 to 46 foot-pounds of torque. And finally, 5/8 requires 50 to 60 foot-pounds of torque. And again, both of these processes are considered absolutely essential to any ductless installation. Dedicated 410A flaring tool, dedicated torque wrenches to make sure that we're torquing down those fittings properly. Okay, good and tight will not cut it. If you over tighten them, you can crack the face of a flare and you'll start leaking refrigerant. Again, making sure you have the right tools to do the job right the first time. Now on our multi-zone systems, depending on the size of our indoor unit is going to determine the size of our suction line and also our mixed phase. Now, on the suction line, we have adapter fittings that will hook on there. In this case, it'll go from a 3/8 suction up to a 1/2 inch suction on larger indoor units. Now, this is going to be indoor units that are 18,000 BTUs or larger is when we need this multi-zone piping adapter fitting to bring the suction line size up to 1/2 inch. Okay, now if you look to the top right on the picture there, you'll see you have your adapter, which hooks on the threads at the outdoor unit. But the most important part is this little copper seal right here, or the ring. You need to make sure that when you get this fitting, this part right here that's going to hook on your service valve, you need to make sure you take this and either take some vacuum pump or refrigeration oil, or you can take an iLog and put it on there, insert it in this fitting here so it sits on the little case inside of here, and when you go to tighten down, it creates the seal from this service port onto this fitting. If you don't put this in here and you just put this straight on, you don't have anything sealing that refrigerant from leaking out, and it will leak out at a very fast rate. So it's important to make sure that we take this copper fitting here and we put this inside the adapter when we tighten on the service valve fitting. And then from there, on this side is where we take our pipe that comes from the indoor unit that's flared and has a nut, and this is where we're hooking up that connection. Okay, if you don't have one of these copper fittings that came with your adapter, please give me a call. I carry a bunch of them as backup, and I can always send you out one depending on if you need one or if you need 5 or 6. Just please make sure that that's inserted in there. Otherwise, you're going to have a very large leak. Now with wiring, this is going to be the most important part. So just as a basic rule of thumb, on 115 volt models, we have our L, N, and S connections. Outdoor unit on ductless systems always powers the indoor unit. Same thing with the 208, 230. Only difference is we have L1, L2, and S. Okay. Communication is carried between the L2 and S on the 208, 230 models, and on 115 volt models, it's carried between the N and S. Now, the biggest thing is going to be, guys always ask me, well, I've used solid wires on these ductless systems before and never had any issues. How come Carrier is saying that we can't use solid wire, we have to use stranded? Well, let's get into it and understand the basics. So first, we must understand that communication is carried between the L2 and the S terminals. And on the 115 volt systems, we know it's carried between the N and the S terminals. So we know stranded wires are a much better conductor of electrons, or in the case that we're dealing with, in communicating DC voltage from our outdoor unit to our indoor unit. Solid wires are more prone to metal fatigue when bent multiple times. So you can see if you're feeding that wire through a difficult area or difficult areas, the more you bend that wire, the more chance with a solid wire that it has to actually break and crack, which in turn, if you're using that for a signal wire, can cause signal interferences and communication codes. Okay, so we look at stranded wires due to their construction are much more malleable and maintain their integrity when multiple bends are required to power or provide that signal. Now, the factory does require 14 gauge stranded wire. Okay, both solid and stranded wires will work. It's not that solid won't work, but we look at if we have an application where we're going to be feeding power wire through multiple different bends, or we're snaking it through different areas, stranded wire in that application is going to be the best suited, just because of how the solid wire, its physical makeup is. The more bends you have in it, the more risk you have of actually cracking the wire, cracking the copper, and essentially causing a signal interference. So it's not that solid won't work, it will, but stranded is much more malleable and much more easier to deal with, especially with the ductless applications on how we're routing the power wire. Okay, so don't think that solid won't work, because it will. It just depends on application, and more importantly, the factory does require 14 gauge stranded wire. So you can see in this application, we have our main power coming from our disconnect, which feeds into the outdoor unit. We have our L1, L2, and S terminals that feed from that outdoor unit bus bar to our indoor unit bus bar on the L1, L2, and S terminals. The factory recommendation for the control wire is 14-3 stranded wire with a ground to ensure proper communication. Okay. Of course, we don't recommend the BX or the MC style wiring, just because we're carrying high voltage and communication typically all in one jacket. Now you can see on here in the multi-zones, this is where things can get a little tricky, and why it's extremely important to label your power and communication lines when you have a 5-headed, a 4-headed, or a 3-headed system. Now you can see on here you have your L1 and L2 for zone A, zone B, zone C, D, and E. So it's very easy to get these lines crisscrossed. And what happens is when you crisscross these lines and you go to start everything up and you fire off everything at once, if you have a zone that's crisscrossed, well, everything's getting refrigerant, so you're not going to be able to pick up on a cross line. What's going to happen is you're going to fire everything off all at once, start the system up, everything looks great in heat, everything looks great and cool. As the system starts to satisfy and we start getting different zones coming on at different times, we're going to send refrigerant out to a zone that isn't calling for it, and it can cause, in cooling mode, icing up on the coil, or in heating mode, it's going to pretty much not heat at all. So we'll get into that in a minute, but again, the most important part to take out of this, label your power and your control wires. Otherwise, you are going to run into a multitude of headaches. And just as a note on the newer style systems, these L1, L2s are now labeled as 1, 2, and 3 on here. 1 being L1, 2 being L2, and 3 being your signal. So you will see that on the newer multi and single zone products. So again, we need to make sure that all wiring sizes, breaker sizes, disconnect requirements should be done in accordance with NEC, CEC, and most importantly, your local code for electric wiring. Okay, and again, always make sure that you use color-coded labels for your power and communication so that you do not get those signal wires and power wires crossed. Okay, now this is my favorite one. I always call this the snow cone syndrome, and this typically happens in the summertime with a brand new installation. So you get a service call, you're out on the service call, and you go up to the outdoor unit, and this is what you see. Okay, you see your snow cone syndrome. So you go, okay, well, what causes this? Remember we were talking about the multi-zone situations where you can crisscross wires? This is a syndrome of that. So what happens is when you cross, let's just say zone A and zone B. And zone B and zone A are now crisscrossed with wiring. So zone A calls, but zone B is getting refrigerant. And that fan's not running. So the fan's not running, it's getting mixed phase refrigerant, and it's not boiling off properly into a suction gas because we're not passing air across the coil. From there, we're now feeding that mixed phase gas back to the outdoor unit where it eventually boils off. And now, because we share a common line suction header, we're going to start frosting up at the outdoor unit. So in this case, the frosting may have started here, but because all of these suction lines feed back to a common header, eventually that ice is going to build up on this and work its way to this, and work its way to that, and work its way down here, and leading to this snow cone syndrome, or essentially where you have all your service valves that are frosted. Now, this one was running for quite some time, which obviously allowed the buildup of ice on that outdoor unit. But typically, you'll start to see this as it runs and runs and runs, that ice will increase worse and worse and worse. Another great way to tell this is if you're calling for cooling for a zone and you're not getting cooling out of that zone, and on another unit, you're frosting up. That's usually a good indication of which units are crisscrossed, and then you know to go back, defrost the ice, correct your wiring, and retest. The correct way with a multi-zone to be able to properly start these up is going to be running each zone one by one and recording a delta T, so return air versus supply air reading on your indoor units, and not running everything all at once, because this is a great way on startup. If you're running one unit by one unit by one unit, you can pick up on a crossed wire scenario and not have to come back after the fact. So don't run everything at once. You need to run it one by one by one, and that stands for heat and stands for cooling modes. And of course, it's recommended by the factory that you always separate your signal wire from the main power wire in areas that have smart TVs and commercial applications that have building automation systems. Again, because you can get signal interference. I always tell guys, and not everyone does it, but it's a good rule of thumb, to take a separate 14 gauge 2-conductor stranded shielded wire and run it with your power and signal cable, and just create a little loop at the indoor unit and at the outdoor unit, so that if you ever run into a situation where you're getting inductive voltage or crosstalking between the main power and the signal, that you already have a wire ran that's shielded, that's stranded, that you could hook up on the signal wire and essentially stop the communication interferences, or what we'll see from the service side is an E1 error code. Okay, again, just knowing your application, knowing what you're getting into. If you have questions on anything or if you have concerns, you can always call me. I can give you my opinion. We can take a look at it to make sure that you're best suited to avoid this from happening. So on multi-zone units, the nice part is that our single zone and multi-zone systems are all interchangeable. So that means that indoor units are not just proprietary to a single zone system, they will also work on our multi-zone system, whether it's an entry tier, a mid-tier, or a high-tier high-wall unit. They are all interchangeable on the multi-zone system. Now, the single zone setups have their own proprietary, such as the 40 MHH is only compatible with an entry tier outdoor unit. The 40 MAQ is only compatible with a single zone outdoor unit, such as the 38 MAQ. But the 40 MHH, the 40 MAQ, and the 40 MPH, which are all three different tiers of high wall units, low, medium, and high, can all be put on the multi-zone outdoor unit. So they are interchangeable on the multi-zones only. So we've talked about refrigeration piping and proper practices. We've talked about the control wiring and making sure that we label it, and also looking for syndromes of a misapplication where we cross wires and get a frosting, or that snow cone syndrome as I call it, at the outdoor unit. So now once we're getting towards the end of this installation, we need to make sure that we leak test the system. Okay, the leak test must be at 500 to 550 PSIG for at least 1 hour. So apply the pressure to the system, go around to your flare joints, or if you're using press fittings, go around to your press fittings, hit them with the soap bubbles, make sure that they look good. Go ahead and time stamp it for an hour. Once it's held that 500 or 550 for an hour, then we can move into the triple evacuation. So once we've held our pressure, we're going to evacuate the system down to 1500 microns. We're going to wait about 2 to 3 minutes to make sure we're not getting any significant rises in microns. Once we've checked out, we're going to go ahead and pressure back the system to atmospheric, which is 0 PSIG with dry nitrogen. From there, we're going to go ahead and evacuate the system down to 1000 microns. We're going to do the same thing. Wait about 2 to 3 minutes. Once we've got to that 1000 micron point, to make sure we're not getting any significant rises, break the system back to atmospheric, which is 0 PSIG, and then finally pull the system down to 500 microns, and we need to at least hold 500 or better for 30 minutes. Most of the time, we're typically right around 250 to 350 range for microns that we're holding for at least 30 minutes. And of course, you want to make sure that you document it and timestamp it so that you guys cover your butt to make sure that you know that the system was pressure tested and also dehydrated properly. So once we've pressure tested and we've evacuated, now we need to look at the system and say, hey, do we require any additional refrigerant charge? So with ductless systems, all of our line sets are based off of 25 feet for the charge that comes in the outdoor unit. Anything over 25 feet is going to facilitate some form of additional charge in ounces per foot. So in this case, if we look at a 12,000 single zone outdoor unit, our minimum line set length on a ductless system is 10 feet at minimum. Maximum will depend on the tonnage that you're working with. So you can see a 9 and a 12,000 single zone only has a maximum of 82 feet, while a 30 or a 36,000 BTU system can get up to 164 feet. So again, this is something you need to make sure that you look in your installation and service manual to know what your maximum piping length that you can pipe is, and that depends on your tonnage. So for this example, we're going to use our 12,000. We know our minimum is 10 foot. We've met that. We know our maximum is 82 foot. We're not over that. 10, which is the minimum, to 25 feet, which is the basis of that factory charge in the outdoor unit. No refrigerant charge. So if we ran 18 feet, we don't have to do any additional refrigerant charge. We can crack open our service valves and test fire the system. Now let's just say that we ran 35 feet. Okay, well, we've got 35 feet. So if we take 35 feet minus the 25, which accounts for the charge in the outdoor unit and what it's good for, we're 10 foot over the design, which is 25 feet. So now what we'll do is we'll take that 10 foot and multiply it by 0.16 ounces per foot. And that will give us our additional ounces that we need to add into the system based on our line set. Okay, and the most important part, it is ounces per foot, not pounds per foot. Okay, typically on these systems, you're really not going to be adding much more than a couple ounces at most to the system, not a couple pounds. And of course, if you have any questions on this or you're running into any issues, you can always call me. I have software that you can give me total line set lengths that I could just spit out an additional charge for you. But I always tell guys, it's really important just to learn the basics, just in case I'm not available to get a hold of, that you have the ability to be able to go there and calculate your additional charge. Now, looking at the additional charge in the multi-zones, you'll see on here on your size 18,000, which is the smallest multi-zone that we have 2 zones on here. And you'll see on here your additional charge required is 49 feet. Wait a minute, I thought you said it was 25 feet. Well, remember, you have 2 zones. You take that 49 divided by 2, you're at about 25 feet, and that's what that factory charge is good for. Now, as you can see on here, you have 3 zones. Additional charge is required at 74. 4 zones, additional charge is required after 98. So as we increase in tonnage, we'll also increase the amount that we have before we start adding additional charge. You can see on here, the multi-zones are nice because they use that 0.16 ounces per foot for all of them, for the ounces per foot additional charge multiplier. And then your total maximum piping length, again, will depend on the tonnage that you have at your outdoor unit. So this is how we go about dealing with the multi-zones. So this 49 foot is between both of these zones, not individual zones. So if between both of these zones we have 60 feet, okay, well, we need to take 60 minus 49, and that's how many feet we're over. Multiply that by 0.16, and that will give us our additional ounces that we need to add into the system. And then finally, you can always reference your product data, your installation data, and your service manuals for all your information. Now, in this case, this is going to be your 38 MGR multi-zones, your 18, 24, 30, 36, and 48. It'll give you your minimum piping length, your standard piping length per each indoor unit, height differences that we have that are allowable, maximum height differences, maximum length per each indoor unit, maximum piping length with no additional refrigerant charge, and then your total maximum piping length between all of your zones. This is where you're going to find all of your information as you're installing it to make sure that you're within the allowable limits. And of course, if for some odd reason you don't have this information, you can always call and ask, and that's what we're here for, to help you guys to make sure that you are applying and installing the systems properly. The last quick thing I wanted to cover on here is if you have a P6 error code on a newer multi-zone system, one thing that we have found, if you look on the picture, is this excess oxidation or corrosion that's building up inside of the body of the expansion valve and also on the post. Now this becomes an issue because we're sending pulse DC voltage to each one of these individual coils, and inside of here this generates a magnetic field, which in turn, when it's on this post, opens the needle and closes the needle to dictate how much refrigerant is going to be fed to the indoor unit. And sometimes this can cause it to become completely closed or all the way stuck open and flooding an indoor unit. If you run into a situation, I always tell guys, if you have a P6 on your indoor unit is not labeled in the service manual. Typically that correlates to a code at the outdoor unit, which is P1 high pressure or P2 low pressure. If you run into a situation where you have confirmed that a P6 is on the indoor or a P1 or P2 is on your outdoor, first verify that the charge is correct. Typically it's associated with a charge code with P2, which is low pressure. If you confirm that your charge is correct, the next thing that I'm going to tell you to check is taking the valve off of the EXV post and verifying that you do not have the corrosion buildup like we see here. If you do have that, please take a picture of it like you see here, and then go ahead and you can take some soapy water and a rag and just go ahead and clean that off. This is a documented issue that we're documenting with Carrier and obviously working to resolve. But it is something that we found in a few circumstances. So again, if you have a situation like this, please take a picture of it. And then in order to resolve it for the time being, just take a wet rag with some soapy water, clean off the inside of the indoor or the EXV coil, and also clean off the post. Okay. So that's what we had for you guys for installation best practices. Hopefully that gave you some insight or just gave you a refresher on what we are supposed to be doing versus what we're not supposed to be doing. And of course, as with every tech tips, I always let you guys know our VRF and ductless training classes for 2021. We're still offering our workshop classes, which are 2-hour classes in the morning from 7 a.m. to 9 a.m. that focus on specific parts of VRF and ductless systems, such as installation, service, application, and troubleshooting. And we also have our traditional 4-hour classes that we do at each branch, which are going to be the 4-hour classes. And this goes over everything from product review to installation to service and to minor troubleshooting and building that process. So those are going to be available all of 2021, both in an online format and in-person format, of course, depending on how the COVID situation unfolds. And then, of course, I always leave you guys with my contact information. So my phone number, direct extension, and email are up there. If for some odd reason you need to get hold of a product manager, both the VRF and the ductless product manager's names, numbers, extensions, and emails are labeled there for you. And one thing I always like to remind you, while I am your first point of contact, I am not your only point of contact. If for some odd reason I'm out of the office or on vacation or just sick or on a startup and I can't get to you, please feel free to call the 3 guys you see listed there with their extensions in our technical support department. John Homan is the service department manager, backed up by Bob Freed and Lee Peterman. So thank you guys for taking the time out of your day to watch us. Hopefully this helped guide you in the right direction, or if you needed a refresher, hopefully this pointed you on what's right and what's wrong. And of course, if you have any questions, comments, concerns, please feel free to reach out to me, shoot me an email, and we'll see you guys on the next Tech Tips.